So it's plugged into the Life 480. So this is not, it's not a joke, not nothing, but it is a built trainer that we had done. So once you turn it on, first thing before you turn it on, make sure you have nothing you observe to be an accident. So go ahead, we'll turn it on. Wow, that would be wishful thinking.
I don't want to be in the way.
If you're ever going to flip a disconnect switch, you stand to the side, look away, throw the switch.
Switch, come over here.
Now, what we're going to do is we're going to use, take the amp meter using the T5-600. I highly recommend purchasing this meter because it's extremely user friendly. And all you got to do is turn the setting to the amps. This is going to be the motor because on the back side, I'm going to take a picture of it. There's a little brake so it can simulate that you have a load on the motor. And then what we're going to do is we'll take the reading, I'll add the brake, we'll record how everything is going to be going up and down with the current when there's a load on it. But check it all out. It's live, so you just be careful. Okay. Can you put it in the hand? I think you're gonna have to hit the hand. Okay. So now the brakes going, or the motor's turning, you can hear it on the back side. So you've got the meter set on the current. You go over one conductor, okay? So all you're gonna do, you're gonna slide this through, and that's what the little blue button down here is hold. So I push the hold button, you pull it out, and it's drawing 0.7 of an amp. Okay, cool. So what does that information actually mean? Well, what you're going to compare it to is the full load current that's stamped on the motor nameplate. So it says that this motor draws 460.61 of an amp, and it's reading 0.7 of an amp. So it's right within its specifications. Now, what I'm going to do is I'm going to push the hold, it'll go back to 0, and I'm going to show you that what would happen if you put a load onto an actual motor. So if the motor is driving a conveyor bearings start going bad, harder for the motor to work, this is what would end up happening. Now, go over one conductor. Can you guys see the meter?
It doesn't matter what conductor?
Just one of them. Okay, now I'm going to put a load on and you'll hear it because there's the little brake I showed you. So ready? What's it at now?
1.1, 1.4.
1.1, 1.4. So I let off. Now I'm putting the load back on it again. Now I've taken it back off and it should settle back down to that 0.7 again. Did it?
Yeah.
So when you're taking the amp reading, if you're using this particular meter, it literally is that easy to figure out what the current is on any of those phases. You just got to go over one of the conductors. And the main reason of showing it to you with the brake, if you're mixing product and mixing, let's say you're making donuts or whatever, and they get the batch wrong, and then the motor's starting to really struggle, if you don't size your overloads appropriately, the motor is going to work too hard and it's going to end up burning up the motor. You got bearings going bad in a conveyor system, motor has to work harder, then it's not going to be able to have the same ampacities because it's laboring, so the current's going to go up. You have a pump and you have something that's too thick, you're trying to pump through it, motor has to work hard, current's going to go up. So whenever you're troubleshooting, you're really trying to figure out, what is the nameplate rated amps, what should it be working at, and then what's causing that amp load or the ampacity to go up on that particular meter. But checking the loads, it literally is that easy. So that's doing one of them. If we turned on some of the other motors, we could also come up here and check one of those conductors at a time. And in that way, it'd be easier on the line side of whatever you're going to actually be going through. So if you want, so that's doing one motor. That's the power that goes to the motor. You want to throw on another one. So now we got two motors. I heard another one kick on. Now we come up here and we check the current. And it's on that. Now it's drawing 1.3. That makes sense. So you're just adding to that actual ampacity But you're checking you're putting the one conductor and the meter at a time to figure out what the current is. So what questions do you have on taking an ampacity reading or measuring the current? Or even a motor question. So when we pulled apart the other motor, you only have the rotor, the part that rotates, your stator, which is your windings, and you have the two bearings on the end. So if you have nothing connected to that particular motor, and you have a higher than it should be ampacity, you have to think, well, what's causing this? Probably one of the bearings on either side of that motor is going bad. Something's going to run to fill.
You can do any gauge, you can do those small wires too?
Any of them. Any one load, as long as you put one conductor through here, it'll take that ampacity reading for you.
And how do you figure out what, like, say the timer went out?
So if the timer was going out, now I'm going to go to the voltage most likely.
Okay.
Because I'm going to see, do I have power to the coil? Is the coil supposed to be on? So that now, like we talk about having to know what the process is of that particular item, what's turning it on? Do I have the voltage there? What's locking it out if it is? And then I'm going to evaluate from that point going opposite direction. So I'll usually go to the coil of, if we have a timer like that, do I have power there? If I do have power there and it's not on, it's either the timer coil's bad or it could be the base, but there's no real moving parts there.
Yeah.
So then it's probably going to be the coil of that particular item.
Froze up. Welded.
Yeah, or inside, weld the contacts inside of it, or it could be that the coil got damaged, someone used an inappropriate
So that's where you
voltage.
say you have to have different sizes.
Right.
That's for the 277.
This can go like, a 2 gauge might fit through here, but I think it has 100 amp maximum ampacity. Yeah, so it's good for 100 amps.
Okay.
So that's what this one. So if you're going to go to larger conductors, get a clamp around meter or whatever it is based upon whatever you're going to be hooking up.
Because I ordered 2 more. They're Milwaukee ones.
Milwaukee's a good name.
I ordered 2 more. The big one, 1,000 watt amp or
Yeah.
1,000 watt. And then I ordered the smaller one, which has the multi.
Yeah, so it has a little